We used a few balance beams and a crane to learn about torque and how cranes work. Okay, Noah, we got a balance beam. Why don't you put one weight at four inches away, and to balance it, you can put another weight at 8 inches away? That didn't work. What should we do? You got one more weight. Where would you want to put it?
We want to put it on the forward because then it would even them out.
So tell me the numbers. Go ahead.
Because
1 pound.
So basically 1 pound on the 8 inches would be 8 inch-pounds, and 2 pounds in the 4 inches would be also 8 inch-pounds. So they would balance each other out.
So the formula is weight times distance on one side equals weight times distance on the other side. Who came up with that idea? Come on, they're telling you.
I don't know.
Who? Come on.
Archimedes.
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 Okay. Okay, Sophia. So there's a balance beam there,
Yes.
and there's two kids 5 feet away from the pivot point,
Yes.
and they weigh 200 pounds. So weight times distance. Tell me some numbers.
Weight times distance equals torque.
Torque. Torque is a turning force, right?
Yes, it is.
So 200 times 5 is 1,000
1,000.
foot-pounds, right?
Huh? Inch pounds? Oh, foot pounds.
Foot-pounds in this case. Okay, and on the other side of the equation, we got just one guy.
Yes.
He only weighs 100 pounds. How far away is he
From
from the pivot point?
10 feet.
So 10 times 100 is,
1,000.
so it balances.
Yeah.
So the torque on one side, counterclockwise, equals the torque clockwise on the other side.
Yes.
That's how the cranes work.
Yeah.
Okay, Noah, we have another balance beam. Give me the numbers.
And this is from the pivot point to this 2 pounds, it's 20 inches, and
Okay.
also from the pivot point to these 4 pounds, it's also 20 inches, but it balances out.
Well, so that's 4 pounds, and the other one is 2 pounds.
Correct.
How come it works?
Because if the center of gravity is right here,
Right.
then you only have to measure the distance from here, the pivot point.
Which
It's
is,
only 10 inches.
okay, so
So,
then I'm going to look at the diagram on the board, which tells us, tell us what it is. 10 inches from where to where?
It's 10 inches from here to here, and 1 inches from the middle point here.
Okay, so 10 inches times 4 pounds, 10 times 4,
it's 40 inch-pounds.
okay. And on the other side of the equation, we have
20 inches times
Tw-
1 pound.
20 inches
Or 2
times 2 pounds equals 40 inch-pounds. So it balances, right? Okay, Evie. So we got a crane there that's like a seesaw, right? Where's the pivot point?
Pivot point is right here.
Well, if you pull on the load, we're going to see the crane begin to tip, right? Now show me where the pivot point is.
Oh, right here.
There you go. Okay. So on one side we have the weight of the crane, which is 10 pounds,
Yeah.
right? I'm going to zoom in there. 10 pounds. So what's the magic formula we're using?
Weight times distance equals torque.
Right. Okay. So the weight of the crane is 10 pounds, and the pivot point, the center of gravity is 12 inches away, which is, show me roughly where it is. About 12 inches from the pivot point, yeah. It's about there. Good. Okay. So and on the other side, we've got the load. What is the load?
This brick.
4.5 pounds.
Oh,
Okay. Now, how far away from the pivot point is that? You don't know. We could take a... Okay, Madison, so we got the 4.5 pound brick hanging there,
yes.
and the crane's not tipping over, right?
No, it isn't.
How come? Show me the numbers.
Because on this side we have 120 inch pounds.
And how do we get that, 120 inch-pounds?
Because it's 12 inches from the pivot point to the crane's center of gravity.
Wonderful, good.
And
And the other side, we have go to the other side where
on the other side,
we have the load.
we have the load, which is 4.5 pounds.
And the distance,
And the distance is 16 inches.
right?
And so 4.5 times 16 is 72 inch-pounds.
Right, so 72 is not nearly as much as 120. That's why it didn't tip over.
Yeah.
What do you think would happen if we left the one brick hanging there, but instead of the boom at 60 degrees, we lowered the boom to 30 degrees? What do you think would happen?
Well, then there would be a lot more distance out, and then there would be more torque on this side.
Say that again. The bigger the distance, the bigger the...
Torque.
Perfect. But how did we find that the distance was 16 inches? Okay, Ben, here's a couple of triangles. They're all 30, 60, 90 triangles. So where's the 30-degree angle?
The 30-degree angle is right here.
Okay.
And
So the short side, like in this one, it's 5 3/4. The short side is, how does that relate to the hypotenuse?
the short side is always half of the hypotenuse, and the hypotenuse is always directly across from the right angle right here.
Right. So 5 3/4 is half of 11 1/2,
Yes.
and 3 3/8 is half of 6 3/4.
Yes.
Okay. So in our crane, the hypotenuse is going to be the boom.
Yes.
Okay, what do we got here?
This is a crane,
Right.
and so the boom is, so the crane weighs 10 pounds, the work weighs 4.5 pounds, and the boom is at a 30-degree angle,
How much?
60, sorry,
That's-
and
okay.
it's at a 60-degree angle, and
It's not tipping over, right?
yeah,
So we're safe.
yeah.
Okay, let's run the numbers. Okay? So the torque is weight times distance, right? We got that up top? Okay. So what's the weight? 10 pounds. And the distance is 12 inches, right? And that gives us 100, come on. Yeah, 120 inch-pounds. Okay, that's 1/2 of the seesaw, right? That triangle is the pivot point.
Yes.
On the other side, we have the load and the boom. Now, the boom weighs, let's say, 1/2 pound, so the total load is 4.5 plus 5.5 is 5 pounds, right? Come on, guys, wake up. 5 pounds, and what's the distance?
It is,
We didn't figure that out yet, did we?
No.
How long is the boom?
it's 32 inches.
32 inches. And remember, in the 30, 60, 90 triangle, the short side is always,
Half of it.
okay, so we got 16 inches, right?
Yep.
So 16 inches times 5 pounds is 80. Good. 80 what? Cantaloupes? 80 inch pounds.
Or 80.
80 inch pounds. Now, so on the right side of the equation, we have 80 inch pounds. On the other side, we have 120.
Yep.
That's why it didn't tip over.
Yay.
Now, what do you think would happen if we changed the boom to 30 degrees? Now, okay, so we changed the angle of the boom. Now it's at 30 degrees, like on the board there. We still have the brick at 4.5 pounds. Okay, so hang the load on the hook there. Let it go.
Okay.
All right, show us what would happen if you weren't there.
Okay, so it would
No, if you weren't there. There we go.
It would fall.
It would tip over, okay.
The boom would go boom.
The boom would go boom, yes. So let's run the numbers up there. Come on, go up to the board.
Maybe, or
Go ahead. So we still have 10 pounds. Go ahead, write it down. 10 pounds underneath. Here's the formula. Weight times distance equals torque. 10 pounds times, what's the distance?
12 inches.
12 inches equals, and on top of the equals, put a question mark. Okay, so on the other side we have 4.5 pounds, right? Now we got to figure out what the distance is. Or write down 4.5 pounds, oh, no, there you go. 4.5 pounds times D, put in a big D.
Whatever this is.
Okay. With our 30, 60, 90 triangle, we saw that the short side is always half the hypotenuse. So we multiply the length of the boom, that's the hypotenuse, by 0.5 to get the distance. Now the boom is at a 30-degree angle. We can use the same 30, 60, 90 triangle, but flipped over. Now the long side, the distance, we get that by multiplying by 0.866. Okay, so
In the end, it's
27.7,
7 inches. You put
That's the
point
distance.
center of the brick.
good. So write that 27.7 where the D is.
And we'd have to multiply that by 4.5, which is the weight of the brick.
Exactly, and that'll give us the
Yeah.
torque, right?
How much? Yeah.
Okay,
So,
so
if the
the crane,
crane is 120 inch-pounds,
right,
and the
load,
and the torque of this side, the load, is 124.7 inch-pounds, then the load is heavier than the crane itself, so it will tip, the boom will fall
perfect.
into a boom.
Evie was holding down the crane off camera. That's why it didn't tip over. Okay, we're going to make this crane, and here are all the pieces. And there's the boom. Okay. Okay, go ahead. Slow on the trigger and put push.
Really slow. Really slow.
Almost.
You have to push more. Really slow.
Perfect. First, we had to lay out where to drill the holes. There will be directions on my website for this. Next, we attach the two sides together by screwing through the sides into the 3 connecting pieces. That's what Sophia is doing.
That's still
Go,
slanted.
straight up and down, 2 hands, push. It's all right.
I want to do it. I'll do this one, I guess.
Here.
Okay, sure.
Come on, guys, we gotta put the string in, straight up and down. Good. Who's next?
Sophia?
Okay, Sophia.
That's tilted.
Come over. Yeah.
That's right, perfect. Slow on the trigger, but you gotta go straight up and down. You got it.